So let's get into task 1. So task 1 is flower identification project where we take in a CSV file, a comma separated value file called as iris.csv, which contains all these data based on already existing flowers, and its species is given here. And when we give a particular range in ilog, we just remove this particular um, row called as ID and then species, because we only want these we only want these columns to determine the type of flower it is, and it has 150 rows and 4 columns. And then again, by using .ilog function, we separate the values and we get only five particular data, and we specify we differentiate the particular data by x and y variables, and then we put it into train underscore test underscore split of function. Here we have the x and y data, and this is optional, completely optional. And to classify this data, we import decision tree classifier and pop tree, and decision tree classifier function is used here so that we can represent it in a decision tree, so that we need to classify it. And dot fit x underscore train y underscore train is also used to fit the values in there, and we predict the x data first, and then we use y prediction. And accuracy, when we want to see whether the result produced by this data training set is correct or not, we get the accuracy in terms of percentage here, and the formula used here is this, and a confusion matrix is drawn here, and for that we use this code, and this is the output produced for Sarosa, and here the row and the column matches, and so this is a correct data, whereas here it is predicted as Virginica, but it's actually Virginica and Sarosa, which doesn't match, so it's wrong. And when you see a value here, it's 1. The actual value is Virginica, but the predicted value is vesicular, so it's not right. So all these diagonal values are the correct ones. The actual ones and predicted ones match, and then here we have a decision tree, which is generated using plot underscore tree of CLF, and it is printed by using dot show of function, and by using naive Bayes theorem from probability we classify it, and the x data is predicted, and then again the accuracy is given, and then here we have a confusion matrix for it also. When we take a look at the task 2, we have an employment analysis. We load a CSV file, unemployment rate up to 11/2020, and it has fields like region, date, frequency, rate of unemployment, and so on. So we take those columns, and then we filter it out by state. The common states are taken, and date, frequency, and so on. When we want to know the actual capacity of this data, it is 267 rows and 9 columns, and the info function provides what kind of data is present here, and so we have object float, integer, and then object float. And when we use df of date, we can convert it into an integer value. We cannot just use non-integer values to predict, and then we have a lambda x used here used in the apply of function, and then when we provide a month's number here, it would easily produce the month name. And then here we use group by month so that the data is grouped by based on the month. And that's it about this. And so let's move on to task 3. In task 3 we are going to estimate a car's price by using already existing cars features like fuel type, aspiration, and its price. So we go for DF columns, which would list all the columns present here, and then we just take the price of all those car data, and then this is that. And when we use label encoder, we just convert these values into integers so that it will be easy to understand. And then that's done here, and then we have to pre-process it by using a standard scaler. So we import it, and then this standard scaler, it makes the existing data to exist in a a common scale, so that it would be easy to differentiate which part of the data is of more value compared to the other parts of data. And again we go for x and y splitting, and then we do linear regression, which would plot those data on a line and then sees which data falls on the line and which doesn't. And here we have an array. The data is fed into the array, and when we find the mean squared error, we get this value, and this is the result. So let's go to task 4. So let's go to task 4, and task 4 involves when many mails are sent, whether it is a spam mail or if it is not a spam mail is detected by this trained dataset. And we also here read a CSV file, and then it goes by these columns. Here we have the message, and we produce new columns like B1 and B2, and it is named as category and message. And so it goes here like this particular table becomes this, and here we have the message, and here we have the category. And when we group by category, and then when we give it describe, this is the output. And label encoder is also used here so that you can identify. It's easy to train the data, and we have integer values here, which is done by label encoder only for category column. It's not for message column, just for category column. And here also we separate it as x and y, and we have an array here, which is like when we read the message go, it makes the value 1 on this particular list, and when we read the message until, it also prints the message 1 the value 1 here. If in case this go is present as third word in this particular sentence, here the value would not be 1 but it would be 2, but that's not the case here, so it is like this. And then we use naive Bayes theorem from probability, and we train the data. And then we have a user interface here, which gets the message to predict, and when we type a particular message, the message goes in here, and vector dot transform of message will transform the message to a predictor. And then if it is equal to 1, it prints spam email. If not, it is not a spam email. So let's move on to task 5. So task 5 is about sales prediction. So we have columns like radio, newspaper, sales, and an unnamed column here, which we would definitely remove. We are going to remove this column and this column so that we use this ranging, and then we get this particular column. And then when we go over to here, we just have the we have taken off some columns, and when we plot advertisements against against sales, we get this. And we plot advertisements, radio advertisements against sales, we get this plot. And then newspaper advertisements against sales, we get this. And then we do standard scalar here too. By standard scalar, we bring it into a standard, like same scale. All of the columns would be in the same scale so that it's easy to compare. And then we get the x and y test data, and we do linear regression here too. And then the x data is predicted, and then the root mean squared error is found out, and then this becomes the result. So thank you for watching.